Okay, let's get started with chapter 14. We're going to skip section 14.1 and dive straight into 14.2. I think we can handle it. So 14.2, permutations and combinations is what we're working on. So we're working on counting things in this section. And so our first objective is to solve counting problems using permutations involving n distinct objects. So n means some amount, and distinct means they're all different from each other. Okay? Skip something? No. Okay. All right, so a permutation in this chapter, in this section, two different things. Permutations is one of them. That's an ordered arrangement of r objects chosen from n objects. So we're picking 3 out of 5, where 3 would be your r and 5 would be your n. And in this case, the order matters. All right, so if we're lining things up later on for a combination, the order will not matter. All right, so there's 3 different types here, and you can jot these down. We'll get into each of them. So the first type is when we have distinct with repetitions. So let's say you wanted to get a code on a keypad 0 through 10, and your code was 999, right? Each number is different from each other, but you're allowed to repeat them. All right. What about distinct without repetition? So this would be something like I wanted to figure out how many different ways I could line people up. Every person is different, right? And I can't pick a person twice if I'm lining them up. And then n objects are not distinct, and we're going to use all of them. For instance, I've got a pile of papers to grade, and I want to sort them into class A and class B, right? So there's a lot of class A and a lot of class B. We'll get into all of these as we go through. All right, so permutations, again, distinct objects with repetition. Let's do the first one here. So here's our first formula. If we are going to pick distinct objects and we're going to allow them to repeat, the formula for all the different ways we could do that, all the different arrangements, is n to the r. All right? N is how many we're picking from. R is how many we're actually choosing. All right, so let's take a look here. The FBI assigns 4-letter codes to various operations, such as ERRT. Notice the repetition of letters is allowed. How many codes are possible? All right, so there's a lot of different code names. We could have code name AAAA, or we could have AZQR. We could pick any letter in sets of 4 of them. All right, so what's the formula here? Again, we go back in here. It's n to the r, where n is the total to choose from, and r is the how many are we choosing. All right. So another way to think about this is how many letters are there for this first slot? There are 26 letters in the alphabet. How many letters could you choose for the second slot? 26 letters there, because we're allowed to repeat. 26 for the third slot and 26 for the fourth slot. And what we're going to do is we're going to multiply them together. So as you can see here, we're going 26 to the fourth because we're picking 4 different slots. All right, so use that thinking for problem 33. Okay, so now we're going to get some new notation. P is going to stand for, if you guess permutation, you are correct, n comma r, where n is how many, again, we're choosing from, and r is how many we're choosing. R has to be less than or equal to n. Repetition not allowed. All right? So here's how this breaks down. P n comma r is n times n minus 1 times n minus 2, all the way through until n, you're to the very last one, just one left. Better formula here as we clean that up is n factorial over n minus r factorial. So this is the one you're going to need to memorize. If you haven't seen factorials before, all right, here's how it works. 4 factorial is 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? So the number multiplying all the way down until 1. Let's try this. Suppose the FBI, for their codes, decided they did not want to repeat. How many different 4-letter codes are there without repetition? All right, so this is permutation because we're picking an order. How many are we choosing from? We're choosing 26. And 4 is what we're choosing. All right, so what we could do here is just write it out without the formula. How many numbers could we choose for the first spot? 26. 25 for the second spot. 24 for the third spot. 23 for the last spot. We'd multiply those together. That's how many not combinations, want to use the right word, arrangements we could have. Now, if we wanted to use the formula here, n factorial over n minus r factorial, it would look like this. 26 factorial over, what's 26 minus 4? 22 factorial. And how that would start is the numerator would be 26 times 25 times 24 times 23 times 22 times 21, etc. And the denominator would be 22 times 21 times 20, etc. But notice what's going to happen. I see a 22 on the top and the bottom. I see a 21 on the top and the bottom. There would be a 20 here as well. We would cancel that. And so what we would be left with is just the 4 numbers on top that we would get here as well. All right, before we move on, let's figure out how to check this on our calculators. If we want to do P26, 4, it's in here. I believe it's in math. Let's make sure. We go to probability, and there it is, NPR. All right, so the key on this, though, you need to actually type in a number first. So 26, we'll go back into math, and number 2, 4, and 358,800 is what 26 times 25 times 24 times 23 equals. All right, let's keep going here. In how many ways can 6 people be lined up? So think about this. How many people are there for the first spot? 6. How many for the second spot? 5. All the way down to 1. This is the same thing as saying choose from 6 people. How many are we going to choose? We're going to choose all 6 of them. Formulaic, 6 factorial over, what's 6 minus 6? 0. And so here's something we need to know. 0 factorial by definition is 1. So this would be 6 factorial over 1, which is 6 factorial, which is exactly what we're saying right here. All right, try problem 35. Okay, so a couple to plug in here. P6, 4. So this is going to be 6 factorial over 6 minus 4 is 2 factorial, which is 6 times 5 times 4 times 3. And we would stop there because the 2's would cancel. 7, 2 would be 7 factorial over 5 factorial. So this would be 7 times 6, because once we hit 5, we'll cancel. And 40, 4 would be 40 factorial over 36 factorial, which would be 40, 39, 38, 37, and then we would stop. All right, so we can plug those into our calculator to get the exact numbers, but that's the setup. All right, after seeing that, try problem 7. Okay, how many ways can we have 4 people have different birthdays, and how many possible ways could this occur? All right, so we've got 4 people here. How many of those 4 people could have the first birthday in the calendar year? 4 of them. There's 3 left for the second. 2 left fighting for the third spot, and then just 1 left there. 4 factorial is 24. There's 24 ways to organize that. All right, so if you have 4 people and we're picking all of them, it's 4 factorial. If you have a situation where you're picking all of them, it's just factorial. Try 47. Okay, let's dive into combinations. So in this case, the key when you're reading through it, the only difference here is that the order does not matter. Okay, we don't care about order for combinations. All right, so list all the combinations of the 4 colors red, green, yellow, and blue, taken 3 at a time. Right, so we could do something like red, red, red. We could do red, red, green. We could do red, red, yellow, right, and so on and so forth. We would pick all of them. Oh, I'm sorry. These are distinct objects. We've got red, green, yellow. Couldn't do that. We could do red, green, and yellow. We could do red, green, and blue. We could do green, right? We could figure all of those out. No repeats allowed. What is C4, 3? The formula is very similar. It's n factorial over n minus r factorial. But we're also going to divide away any repeats because, in this case, red, green, blue is the exact same thing as blue, green, and red, right? Because in this case, we don't care about the order. We picked a red, we picked a blue, we picked a green. It's the exact same thing. All right, so let's plug these in real quick. Let's do the first one by hand, C4, comma 2. So this is 4 factorial over 4 minus 2 factorial, so minus 2 factorial, which is 4 factorial over 2 factorial 2 factorial. So here we're going to have 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Cancel, reduce, and the answer is 6. All right. So what about 5 and 2? So we've got 5 factorial over 5 minus 2 is 3 and a 2. 5, 4, 3, 2, 1 over 3, 2, 1 times 2 times 1. And you'll notice that those all canceled. Those will reduce. 5 times 2 is 10. So you're seeing that the numbers are a lot smaller if we don't care about the order. All right, what is C of n over n? N factorial over n minus n factorial, n factorial. So this is n factorial over 0 factorial, n factorial. Those will cancel. This turns into 1. We're left with 1 over 1, so it's just 1. All right? C of n0 is going to be n factorial over n minus 0 factorial times 0 factorial. N's cancel. We get 1 again. And last one, 40 over 4. We'll have 40 factorial over 36 factorial 4 factorial. So we've got 40, 39, 38, 37. Once we hit 36, we're going to cancel. Over 4, 3, 2, and 1. And what you're going to want to do here is see if you can reduce anything possible. So that would be a 10. Let's see, what else can we do? This is going to be a 13. And we could go in here as well and go 19. And the reason you want to reduce is that really quickly these numbers can get really big. And so if you don't reduce, your calculator might not be able to calculate them if you're multiplying them out. Of course, you can just go into your calculator and do 40 and CR. Which is number 3, 4, and get 91,390. All right, try problem 15. Okay, just a couple things to finish up. How many different committees of 4 can be formed from 8 people? This is one where the order doesn't matter, so it's a C. C 8 comma 4. 8 factorial over 4 factorial 4 factorial, which is 8765 over 4321. 4 times 2 is 8, and 3 goes into 6 twice. So 7 times 5 is 35 times 2 is 70. All right, let's try another one here. So now we use 2 things going on here. We want 3 boys and 2 girls to be formed from a total of 7 boys and 10 girls. We're going to pick a combination of, and here's where you split it up. We're going to choose 7. From 7, we're going to choose 3 boys, and we're going to multiply. We're going to pick from 10 girls, we're going to pick 2 of them. All right, so let's use the calculator real quick to knock this out. And so we've got 7, NCR 3, we've got 10, NCR 2, 35 times 45. Oh, well, let me go and get it. Times 35 is 1575. A lot going on there. All right. Last objective. Solve counting problems using permutation involving n nondistinct objects. Here's your formula. N factorial over n1 factorial, n2 factorial, all the way through until you're done. Write that formula down, and then I'll explain it with an example here. How many different words could you form using the words algebra? Now, here's the key. You could scramble these up, but what if you just switched the letters A? Would you form a new word? No, you wouldn't. All right. So what you want to do here is, how many letters are there total? 1, 2, 3, 4, 5, 6, 7. So 7 factorial over how many different choices do you have? Well, there's 2 A's, there's 1 L, there's 1 E times 1 factorial, there's 1 G, there's 1 B, and there's 1 R. So 1, 2, 3, 4, 5, 6, 7 should match this number here. So in the end, we're doing 7 factorial over 2 factorial, which would be 7 times 6 times 5 times 4 times 3 times 2. All right, that's how many different words you could come up with. All right, similar thing. How many different vertical arrangements of flags are there? If there's 10 total, 5 of them are white, 4 of them are blue, 2 of them are red. So 10, 9, 8, 7, 6. Once we hit 5, we're going to cancel. 4 times 3 times 2 times 1 times 2 times 1. Let's see what we can cancel here. 4 times 2 is an 8, and 3 times 2 is 6. So it's 10 times 9, which is, let's go the other way. 9 times 7 is 63, times 10 is 630. All right, 51 is yours to try, and that will do it. Any questions? We'll go over in class. Good luck.